Now we're going to look at how you combine functions. Combining functions is a process used in many careers such as the business field. Before you can combine functions though, you need to know what values can I use in the domain or the input. Now to be able to do that, let's refresh our memories on a couple of concepts. First, let's look at fractions. Do you recall when a fraction is undefined? It is when the denominator is 0. It is very important in the real world application to never have a fraction with a denominator that's 0. Do you recall when a square root is not a real number but an imaginary number? That's right. That is when its radicand is negative. That is the value underneath the square root radical symbol. Now, this is important to keep in mind because in the functions we'll be looking at, the domain is normally all real numbers. For instance, this first function, function A, is just a domain of all real numbers. I know that because I look at it and I ask myself, is there a fraction that I need to avoid the 0 denominator? No. Is there a square root radical symbol in there? No. So I can just say the domain is all real numbers. All real numbers is written in interval notation as negative infinity to positive infinity. Now, in example B, notice I do have a fraction. When I have a fraction, I must be careful that I do not have a 0 denominator. So think about it. When would x minus 11 equal to 0? Well, if you move that 11 over, that is when it becomes positive 11. So we want a domain that could never ever be the x of 11. Now you think about this. Picture the x-axis. Remember the x-axis goes horizontal. And in the middle is 0. You have all your positive numbers and all your negative numbers out to the left then. Somewhere out here you'll have a positive 11. What we're saying is that we never want positive 11 to be part of the domain, but all numbers larger and all numbers smaller than that can be part of the domain. So the domain here is written as negative infinity up to 11, and we put a U to symbolize the skip over or the jump over 11. Then we have 11 comma infinity. Again, this is interval notation, and that 11 breaks your domain, your x-axis, up into two different intervals. Now in the last example, C, I have the square root symbol. When it is a square root in the original function, you need to avoid negative imaginary numbers. So what you will do is you will take the radicand and you will ask yourself, where is that greater than equal to 0? Because I don't want it to be less than 0. Less than 0 would make it negative. Well, if I solve that, move the 4 over, that would mean everywhere it's greater than equal to negative 4. Notice when the 4 moves over, it becomes a negative. Again, picture the x-axis, which is the horizontal number line. 0 is in the middle. And if I go over here, here is negative 4. This domain says that it has to be greater than equal to negative 4. So it can be anywhere from negative 4 on up. It cannot be anything to the left of negative 4. Now this interval we will write as bracket negative 4 comma infinity. It goes to infinity because it can be any number larger, which is out to the right, of negative 4. Really, the only time we ever use a bracket in this type of interval notation is when you have something like a closed circle right here. See how that was x is greater than or equal to negative 4? That's when you use a bracket. Hopefully, these three examples will help you be able to pick out the domain. A polynomial function is just all real numbers. A fraction, you avoid the 0 denominator. And a square root, you have to avoid the negatives. Okay, now that we've talked about the domain, let's get to the business of actually combining a couple of functions. Whenever you see the plus sign, obviously that means you take the f of x and you add it to the g of x function. So that means we take these terms, x minus 5, and we will add them or combine them to 2x plus 1. It's simply a matter of combining like terms. I have 1x and 2x, which gives me 3x. I have the negative 5 and the positive 1, which gives me negative 4. So the answer to this first example, f plus g, is 3x minus 4. Now, let's go through and let's do subtraction. Subtraction sign means you will take the f of x function terms and subtract the g of x. That will look like this. X minus 5 subtract 2x plus 1. The thing to watch out for when you do subtraction is that negative sign in the middle. That subtraction or negative sign will go with the terms behind it. So I really have x minus 5, subtract 2x, subtract 1. There's a little bit of a sign change. Now I combine my like terms. This understood 1x and negative 2x will give me a negative x. This negative 5 combined with the negative 1 will give me negative 6. So this would be the result when I subtract the functions. Whenever I come down here and see the notation FG, it is understood that that is multiply. So I will take the f of x terms and I will multiply the g of x terms. That will look like this, x minus 5 times 2x plus 1. In this particular case, I notice that I can do the FOIL method. First, outer, inner, last, or if you prefer, you could just do distributive property. When I multiply this out, I get 2x squared, multiply the first terms, then multiply the outer terms, the x and the 1. That will give me 1x. Then multiply the inner terms, the negative 5 and the 2. Multiplied gives me negative 10x. Then multiply the last terms, the negative 5 times the 1. That gives me a negative 5. Notice you can combine like terms to get 2x squared minus 9x minus 5. And that would be my final answer. Now this last one is always my favorite, even though it is a fraction. The fraction is division. That just means to put the f of x over the g of x. F of x would be x minus 5, and that would be over 2x plus 1. And there's nothing to actually work out with division like that. Now, when it comes to the domain of each of these, the first problem, the answer was just a regular polynomial. No fraction, no square root. So my domain, I'll just use the letter D, would be negative infinity to positive infinity. My second answer had no fraction, no square root. The domain is negative infinity, positive infinity. My part C, the answer right down here was just polynomial. It had no fraction, no square root. So its domain would be negative infinity to positive infinity. However, this fraction that was the easiest one to work out, I do have to avoid the 0 denominator. So to get this domain, I will take 2x plus 1 and put it equal to 0 and solve. So I'm going to move that 1 over. It becomes a negative 1. I'm going to divide by 2. Gives me negative 1/2. So on the x-axis, remember 0's in the middle, the number that I want to skip over, because this is a fraction, is a negative 1/2. So my domain here is going to look like this, negative infinity, comma, negative 1/2. Then you put a U to indicate the jump over, the skip. Negative 1/2, comma, infinity. And that's how you combine functions.